Hey everybody, this is Mr. Ainsworth, and let's greet each other properly. Good morning. It's good to see you guys, and I'm glad you're following me here as we go through a lesson on what's called function notation and how to evaluate functions using this crazy notation called function notation. So let's go back in time. Let's do the flux capacitor actually, and do what we've done a long time ago. Let's take a linear function such as y equals 5x minus 3. And let's find y when x is 3. And you've seen this and you've done this before. What we need to do is we need to take our function, all right, which is y equals 5 times whatever x is minus 3. And what we're going to do is we're going to take 3 here, okay, and basically substitute it in. All right, 5 times x, or 5x means 5 times x. So you want to take 5 times your x value minus 3. You want to substitute that in. SB stands for substitute. All right, so let's do that, and let's follow the order of operations, and let's figure this out. Well, we know that 5 times 3 is 15, so y is equal to 15 minus 3, using the order of operations there, and obviously that's 12, so y is 12. All right, and if you want to write this as an ordered pair or as a solution, well, we always write it as x comma y, as you guys know. All right, so for us, this is the same as, let me see, x is 3. And y is 12, so 3 comma 12. All right, but that's the y value when x is 3, and y changes or y varies depending on what x is. This is what we did a long time ago. This is the old way. All right, now let's do it the new way with what's called function notation. So I want to start off by saying something really crazy. I'm going to say let, all right, y equal what's called f of x. All right, you say this, okay, as f of x. F of x. That's how you say it. So everybody say f of x. All right, good job. Now, a lot of people think this is being multiplied. F is being multiplied by x here because they see the parentheses. And that's not the case. It's just a notation, guys. It's a notation. So it's just another way of saying y. All right, now if we take our function over here, the one that we're working with, y equals 5x minus 3, and I rewrite it in a function notation, well, it looks like this, f of x. Everybody say f of x is equal to 5 times whatever x is, and I'm going to put in parentheses, minus 3. 5x means 5 times x. So what you really want to do is, if I give you your x value, you can find out what f of that value is at any time. You want to substitute in, right there, SUB stands for substitute, whatever x is in this function notation. So if I said this, if I say find, all right, f of 3, which is basically saying find the value of the function, in this case f is like a function, all right, evaluate at 3, what I want to do is substitute that in. All right, 5 times my value of x, which is 3 in this case, minus 3. And then I work it out. 5 times 3 is 15, minus 3, and I get f of 3 now, not f times 3, but say f of 3, all right, is equal to 12, where x is 3 and my y value is 12. It's the same thing as what we did a year or two ago, all right, when you were beginning this substitution process. It's just using this new notation called function notation. And some of you guys may have seen it before, all right, so it's not so new, all right, but if you haven't, here it is. And like anything in mathematics, you just have to get used to it. All right, so what we're going to do is we're going to do it quite a few times. And pay attention to how it's written, okay? And pay attention also to how it's said. All right, this is not f times 3. This is f of 3, which means find the value of the function at x equals 3. Find the value of the function at x equals 3. That's what this means. In fact, let me write that down here. Find the value, all right, of the function, okay, at x equals 3. That's what we're doing here. All right, so let's highlight that. F of 3 means find the value of the function at x equals 3. So let's get some experience here, because that's exactly what you need, and work with a bunch of different functions at many different values of x. Okay, now my first function here that I want to take a look at is f of x. Say f of x equals 6 times x minus 5. So let's bring it over here. All right, f of x is equal to 6 times x, I'm going to put in parentheses here, minus 5. And once again, whatever that value is, you're going to substitute it in and evaluate the function at that point. I'm going to do it 3 different times here. So my first one here, let's come over here, is f of 2. So I'm going to take 2 now and substitute it in my function wherever I see x. So I have 6 times 2, all right, minus 5. And I left plenty of room here on the right-hand side so you guys can work it out stepwise. Well, that's equal to 12 minus 5, or that's equal to 7. So we say f of 2 is equal to 7, where x is 2 now and y is 7. It's actually an ordered pair, 2, 7. Now let's try it again. So you can substitute any number you want. Positives, negatives, 0, fractions. I mean, you just got to get used to it. So everybody say f of negative 3. All right, you're going to take 6 times that negative 3 minus 5. Again, you substitute it in. That's all you do. And then evaluate. 6 times negative 3 is negative 18 minus 5. Let me see if we add the opposite here. A negative plus a negative is a bigger negative. And so I get a negative 23. So we say that f of negative 3 equals negative 23, where x is negative 3 and y is negative 23. Okay, you got to understand what's going on. And then my third one here, f of 0, well, this one's easy, right? All right, 6 times 0, once again, I substitute that in, minus 5. Well, anything times 0 is 0, minus 5 gives you a negative 5. So we say that f of 0 equals negative 5. And that's how it's done. You just want to take this value of x right here and substitute it into the function, right here and right here. You physically take that value and substitute it in, SUB for short. So wherever you see x, you put the value of x into the function and evaluate it. Okay, so right here I substituted 2 in, here I substituted negative 3 in, and here I substituted 0 in. Exactly where you see the function, see right here? Excuse me, exactly where you see the value of x, okay? And that's all we do, and then you use order of operations. And it's something that after you do this a few times, you kind of get used to it. Like on the second example, and I'm going to do a few so you can see the different variety and the different ways of doing things. On this next one here, we're going to do the same thing though, but we got to substitute in inside the quantity here. 2 times the quantity of 3 times x minus 1. Oh, let me pause for a second. I want you guys to pause and play through my videos here. Pause and play and rewind, okay, if necessary. Rewind. Oops, rewind. There we go. At any time. Pause, play, rewind. Do whatever you need to do. Listen to it 2-3 times. If I go too fast, slow me down, okay? All right, so let's try it again. Let's take this function off to the right. Everybody say f of x equals 2 times 3x, now that's times x here, all right, minus 1. I need to take this right here, this value, whatever value it is, and substitute it in for x. So I'm going to write substitute right there, all right. Now the first one is f of 2. It's 2 times 3 times 2 minus 1. And if you understand just basic arithmetic here and order of operations, you know, and what to do at a particular time, this is not that bad. Okay, so let's work this out. We got 2 times 6 minus 1, or 2 times 5, right? 6 minus 1 is usually 5, or 10. All right, so we say that f of 2 is 10, where x is 2 and y is 10. That's all there is to it. The next one, f of negative 3 again. Well, let me see, I got to substitute it right here. This is where my variable is. So it's 2 times 3 times a negative 3 minus 1. I substitute it in here, and I figure it out. So it's 2 times, let me see, 3 times negative 3 is negative 9 minus 1, and that's 2 times negative 10, and well, that's got to be what? That's got to be negative 20, right? So when x is negative 3, y is negative 20, and that's all there is to it. Last one, f of 0. So what does that look like? Well, I love zeros, man, because 0 times anything is itself. So here we have 2 times 3 times 0 minus 1 is 2 times 0 minus 1. What is that? 2 times negative 1, because 0 minus 1 is negative 1, right? And that gives me negative 2. So when x is 0, y is negative 2. All right, and if you do practice like this, when the light bulb goes on, you go, oh man, this stuff looks gnarly, but it's not that bad at all. All right, now let's get you involved here a little bit. All right, now we're going to take the function off to the side. All right, we always do our work on the other side. F of x, everybody say f of x equals x plus 14 divided by 4. All right, and we're going to, again, we're going to, wherever we see x, we're going to substitute that value in. I need to substitute it right here. That's the only spot. Add 14, whatever I get, divide by 4. All right. Now, I want to find out what f of negative 6 is. So why don't you do this? We're going to pause and play through the video now. Okay. So someone has to be on the mic, on the mouse, pausing and playing. Pause, play and pause, pause and play. Whatever. I just got it backwards, but you understand my point. Pause and play. Pause the video right now. Give it a shot. And in about, I'd say 15 seconds, press play and watch the solution, and let's see if you get it right. All right, so take yourself through the video by pausing and playing, okay? Pause it right now, get started. All right, let's check your work now. We're going to take negative 6 and substitute right here. We have to add 14. What do we get divided by 4? Negative 6 and 14 is 8. Divided by 4 is 2. See? We want to substitute it right there. Easy, okay? Wherever you see x, you substitute it in. And that's all there is, and you follow the order of operations. All right, now you try f of negative 1. Pause the video, go for it. All right, time to check your work. We got to take negative 1 plus 14 divided by 4. That's 13 divided by 4. And that is, let me see, 4 divides into 13 3 times. With 1 remaining, you get 3 1/4. All right, did you get it right? If not, check your work, fix it off to the side, okay, and mark your mistakes. All right, all you want to do is just substitute in wherever you see x. All right, next one, f of 0. Pause the video, give it a shot. All right, now let's check your work. Got to go 0 plus 14 divided by 4. That's 14/4. And that's 3 divides into 3 times with 2 remaining, so 2/4. And if you simplify a little bit, you get 3 1/2, not 3 1/4, 3 1/2. All right, now let's try another one here. Let's, just experience a wide variety of functions here. All right, so now in this one here, f of x is equal to 3 times a quantity, x plus 2, quantity squared. All right, and then here we're going to add 2 to x first, square it, and then multiply by 3. But first you got to show the substitution. All right, I want to see that on everybody's work, okay? So the first one here is f of negative 6. So everybody say f of negative 6. All right, pause the video and give it a shot. All right, time to check our work. So we've got 3 times negative 6 plus 2 quantity squared. That's equal to 3 times, let me see, negative 6 plus 2 is negative 4 squared. Let me see, negative 4 squared is negative 4 times negative 4, which is 16. So 3 times 16, and that's 48. All right, you have to simplify here, square here, all right, and then multiply, and you get 48. Step it out. Okay, next one. Let's evaluate the function at negative 1. So find f of negative 1. Pause and play. All right, pause the video. All right, let's check. So 3 times negative 1 plus 2 squared is 3 times 1 squared. Negative 1 plus 2 is 1. 1 squared is 1, so 3 times 1, well, that's 3. All right, notice how I'm stepping it out, okay? And everybody right on the left-hand side, step it out. Okay, I need to see your process, okay? Show me your thinking. Show me your thinking. Okay, every instructor wants to see your thinking, so you got to show me things. All right, show me how it's done. Show me how it's generated. All right, next one here, f of 0. Substitute 0 in right there and give it a shot. All right, now let's check our work. We got 3 times 0 plus 2 quantity squared. 0 plus 2 is 2, so you get 3 times 2 squared, which is 3 times 4. 2 squared is obviously 4, and you get a total of 12. Okay? Not bad, not bad. All I did was I substituted -6 in and then simplified. Then I substituted -1 in and then I simplified. Then I substituted 0 in and then I simplify. All right? Following the order of operations. All right, now let's take a look at the next example here. On this one here, we've got f of x, everybody say f of x, is equal to x minus 4 times the quantity x plus 3. Now on this one here, we got to substitute in 2 locations, here and here. Aha! All right, so let me lead you on this first one here. So we got f of -6 again. All right, I have to substitute it here and here twice. So that's going to be -6 minus 4 times a quantity, -6 plus 3. Now notice, I substituted in 2 locations because x is located in 2 locations here. Because the function is not so simple anymore, is it? All right, but actually it's not that bad because -6 minus 4 is -10. -6 plus 3 is -3. And when you multiply them together, you get 30. All right, so f of -6 is 30, which means when x is -6, y is 30. And that's all there is to it, my friends. We just got to get good at it. So let's try it again, all right? Let's try f of -1. All right, pause the video and go for it. All right. Now on this one here, we're going to take -1 minus 4 and then -1 plus 3 and then simplify. All right, -1 minus 4 is -5. -1 plus 3 is 2. When you multiply them, you get -10. So f of -1 is 10, which means when x is -1, y is -10. All right, now c, what's f of 0? Well, that's easy. You got 0 minus 4 times 0 plus 3. Pause the video, go for it. Finish. All right, you're back now, so let's take -4 times 3. Ooh, you get -12. All right, easy. All right, now for my last example here, I got this square root function, okay? Let's bring it down here so we have a little bit more room. All right, f of x is equal to 2 times the square root of x plus 5. All right, what I need to do is take whatever x is and substitute it into the function. And once again, this is a video, so I'm just going to remind you until you guys get the hang of this. You can pause it anytime you want. If I'm going too fast, then slow me down. All right, let's do part A. Let's find f of -1. Let's take 2 times the square root of -1 plus 5. All right, notice how I just substituted it in there, right? And that's the same thing as 2 times the square root of 4. And that's the same thing as 2 times 2, because the square root of 4 is 2. All right, and that's 4. Let's try to evaluate the function at 4 now. All right. 2 times the square root of 4 plus 5, okay? Substitute in 4. And that's 2 times the square root of 9. What's the square root of 9, everybody? That's right, it's 3, so you have 2 times 3 here, and that's 6. And that's all there is to it, man. All right, last one, f of 20. So we get 2 times the square root of 20 plus 5. Substitute the 20 in. And you get 2 times the square root of 25. Everybody tell the person next to you what the square root of 25 is. That's right, it's 5, so you get 2 times 5, and that is 10. So f of 20 is 10, which means when x is 20, y is 10. Okay? So really pay attention to how I'm writing this, because I'm going to evaluate you guys and watch how you guys write it and say it and act on it, okay? And you want to do it right, say it right, perform it right. This is like, write it, say it, and do it correctly. There's a lot to this lesson here called function notation, but it's all pretty simple arithmetic, okay? Now you've got your own practice to do, so turn on the next page, and you're going to see your homework here. All right, now you're going to be evaluating all the different functions here, and I don't always use the same letter. It could be f of t. Instead of x, I use t. Instead of the function f, I use g function, or the function h, or the function p, because in the applied sciences, they don't use the same variables all the time. They use variables that make sense to the situation. Like P could stand for pressure, and G can stand for, I don't know, gas, and then H can stand for height, and W could stand for width. All right, so you got to go with the flow here and just do what's asked for. Like here in this first one, it's G of 8. So you start off here, G of 8, and that's going to be equal to something, right? You want to take X and substitute that in. Ooh, not just in one location, but in two locations. So your first one is going to look like, 8x minus 4 times 8. And then you simplify it and step it out. All right, step it out, do your best, and then always check your work. And you're probably going to say, hey, how, right? Well, let me see. Did I include the answers? Yes, I did. Okay, it's on the last page. So make sure you do that. You check your work, step it out. I want to see this entire area just filled with step, step, step. Okay, equal all these steps, and step it out. Do your best and check your work as you go. Put question marks next to anything you need help with, and I will be back to you soon when I see you in class. All right, do your best, be proud, and make me proud of you. I'll see you later. This is Mr. Ainsworth signing off. Bye-bye.